Hey guys, in this one we're going to take a look at another way that we can think about doing the binomial expansion, which is by factorising. Now in this video in particular, we're going to be using this skill to help us find specific terms in an expansion. So, first of all, let's just start with A plus B. Now we could factorise that to A times 1 plus B over A. No problem. Now, if we apply this to a binomial expansion of the form A plus B to the power of n, well, we could write this as, first of all, A times 1 plus B over A, and that would all be to the power of n. Now if we let that power of n in, we've got A to the power of n times 1 plus B over A, all to the power of n. Now, why is this useful, I hear you asking? Well, if we do this, we can actually use the formula in its less scary form. So, if we now wanted to expand this out, well, we would have A to the power of n times, well, 1 plus n choose 1 times B over A. And then plus n choose 2, lots of B over A all squared. So what's happening inside of the expansion, instead of worrying about two different terms being set to powers, by factorising that A term out, we've reduced one of the terms in the expansion to just A1. So this is just going to carry on. We're then going to have n choose 3, lots of B over A cubed. Now this is just going to carry on all the way up to plus 1 lot of B over A all to the power of n. But remember, everything inside of those big square brackets are now being multiplied by A to the power of n. So, this might look a little bit scary when it's fully algebraic, but it does actually make things a little bit simpler for some questions, as we'll see now. Okay, first example then, so we want to find the coefficient of the x to the power 4 term in the expansion of 2 plus 3x to the power of 8. So, let's first of all only worry about 2 plus 3x. So 2 plus 3x can be written as 2 lots of 1 plus 3 halves x, like that. So we can write then 2 plus 3x to the power of 8 as 2 to the power of 8 times 1 plus 3 halves x to the power of 8. So, if we were to do the whole expansion of 1 plus 3 halves x to the power of 8, we would then multiply every term by 2 to the power of 8. But we're not going to do that. So what we want is only the x to the power 4 term. So, first up, we just find the x to the power 4 term of the expansion of 1 plus 3 halves x to the power of 8. When we find that, we then have to multiply it by 2 to the power 8. So, the x to the 4 term in the binomial expansion is going to be, well, it's going to be 8 choose 4 times 3 halves x all to the power of 4. So, if we whack this in our calculator, 8 choose 4 is 70. 3 halves to the power of 4 is, well, 3 to the power of 4 is 81. So we get 81 x to the power of 4 over 2 to the power of 4, which is 16. So there's a common factor of 2 between 70 and 16. So this goes down to 35 times 81 x to the 4 all over 8, which is 2,835 over 8, lots of x to the power of 4. So, that's our x to the power 4 term of just the binomial expansion. Now, we need to multiply it by the 2 to the power of 8. So, our answer to the original question is 2 to the power of 8 times 2,835 x to the power of 4 over 8. Now, 8 is 2 to the power of 3, so we can simplify this to 2 to the power of 5 times 2,835 x to the power of 4, which gives us 90,720 x to the power 4. So with numbers like this, it's easy to see why they would only ask us to work out the coefficient of one term. What a bully. Okay, let's do one more. Okay, example 2 then. So we want to find the coefficient of x cubed in the expansion 5 plus 2x to the power of 5. So, if we factor out the 5, we get 5 to the power of 5 times 1 plus 2/5 x all to the power 5. So that's the factorising part done. Now, we just look at the binomial expansion part. So we want the x cubed term from this. So, this is going to be 5 choose 3 lots of 2/5 x to the power 3. So, if we work that in our calculators, well, 5 choose 3 is 10. So we've got 10 times, well, 2/5 cubed is going to give us 8x cubed over 125. So, hoping I can do this without a calculator. This is going to give us 80 x cubed over 125, which then has a common factor of 5, so it's 16 x cubed over 25. So that is the x cubed term just of the binomial expansion of 1 plus 2/5 x to the power of 5. Now we need to multiply that by 5 to the power of 5. So, our answer is 5 to the power of 5 times 16 x cubed over, well, 25 is 5 squared. So, I'm going to write it like that. So now we can cancel out a factor of 5 squared. So we've now got 5 cubed times 16 x cubed. 5 cubed is 125 times 16 x cubed. 16 times 125 is gonna be 2000. So, our answer is 2000 x cubed. Jobs again. If you want any more like this, guys, let me know in the comments down below. For now, though, that's it. Take it easy.